2. Okay, same thing. We're deciding, do they have anything in common? So look at our coefficients first. We have 12 and 20. What do we think the GCF, greatest common factor, between 12 and 20? What's the biggest number I could divide both those guys by? What do you think? Nora? 4. I agree. We can divide 12 by 4, and we can divide 20 by 4. You might have said 2, but is 2 the biggest number you could divide it by? Nope, 4 is. We want to take the biggest one. So we can take out a 4. Okay, so now I look for my variables. If I have one n right there, and then no n's, can I take an n out? Do they have an n in common? No. Nope. The only thing I could take out was that 4. Now we just decide what's left inside when we divide or factor it out. Okay, what is 12 divided by 4? Ricky? 3. And then we didn't take the n away, so it's still 3n. Okay, then I have negative 20 divided by 4. Ricky?
5.
Positive 5? Negative 5. So final answer, 4 times 3n minus 5. Beautiful. Okay, let's try it again. Ooh, get some higher powers going in here. First things first, we got to look at our coefficients, 2 and 6. What is the GCF, biggest number I could divide both 2 and 6 by? What do you think? Raise your hand if you know it. Nora? 2. I can divide 2 by 2. I can divide 6 by 2. So we can take out a 2. Okay, now what about the variables? This guy has 4 x's. This guy has 2 x's. Remember, you can take the smaller amount. How many x's can I take out, Carl?
2.
2. So x squared. Okay, now last step, what's left inside when we divided or factored it out? Okay, what is 2 divided by 2? Ricky?
1.
1, and then if I had 4 x's to begin with, but then I divided 2 out, how many do I have left? 2. So I have 1, which we don't have to write, but then 2 x's left from that first term. Okay, let's do the same thing with our second term. What's 6 divided by 2? Nora?
3.
Positive 3. And then I had 2 x's on this guy, but then I divided all 2 of them or took all 2 of them away. Do I have any x's left? Nope. So final answer, 2x squared times x squared plus 3. Great job. Okay, last binomial, last 2-termed guy. Look at your coefficients, 7 and 42. What's the biggest number I could divide both 7 and 42 by? Ricky, think you have it? 7, beautiful. I can divide 7 by 7. I can divide 42 by 7. Beautiful.
I'm just about to double check to see if something.
Yep, you got it. Okay, now we look at our variables. If this guy has 5 v's, but my second guy doesn't have any v's, can I take v's away?
No.
Nope, they both don't have them. Okay, so the only thing we could take out was that 7. Okay, let's figure out what's left when we divide out that 7. What is 7 divided by 7?
0. No. V5?
V5, 1, v to the 5th. Beautiful, because that turns into 1. Then we still have all 5 of our v's left, so v to the 5th. You don't have to put the 1 in front, right? Okay, but then what is 42 divided by 7? What's my next term going to be?
6.
Positive 6. So final answer, 7 times v to the 5th plus 6. Awesome. Especially since I haven't been here for like a week. Show me a fist to 5 on factoring binomials, 2-termed guys. Love it. Even if you're like a 3, I'm happy. Okay, now comes, in my opinion, the easier / more fun stuff. Factoring quadratics. Okay, but let's look at number 5. Remember, when factoring, always, always, always check to see if there's something they have in common. Okay, so look at the numbers. 3, 27, and 42. Is there a number I can divide all 3 of those guys by, Cindy? You may. Is there a number I can divide all 3 of those guys by?
2.
Not 2, because I see some odd ones. What is it?
3.
It's 3, right? I can divide 3 by all of those guys. They have a 3 in common. So we got to take out that 3. Okay? So just like when we were factoring binomials, they had that 3 in common. Let's figure out what's left over when we take it out. What is 3 divided by the 3?
N squared.
Just 1, so that just turns into n squared, 1n squared. What's negative 7, or excuse me, 27 divided by 3? Negative 9, and then the 1n left by that guy. What's 42 divided by the 3?
7.
Positive 7. Is that? Wait. Wait. Calculator. 42 divided by 7. 6. Okay, beautiful. So then positive 6. Wait, is that true? No. 42 divided by 3. Huh.
That's what he.
Yes, okay. I was like, where did I get that? Okay, cool. That'll work now. Beautiful. Okay. So now, this guy is not all the way factored. Okay, we still can factor him because we're going to ignore the 3 out in front. This just turns into a regular quadratic. Now we play the number game with him. Okay, so let's look at our last number, 14. Okay, always start looking at your last number. I need 2 numbers that'll multiply to give me a positive 14, but are going to add to the middle guy of negative 9. Don't worry about the negative 9. Just give me 2 numbers that could multiply to 14. What do we think? 2 numbers that could multiply to 14.
2 and 7.
Beautiful. 2 and 7. 2 times 7 will give me 14. Okay, what happens when we add 2 and 7? 2 plus 7.
9.
Positive 9. Ooh, so close. Are we looking for positive 9?
Negative.
So what do we need to do to that 2 and 7?
Negative 2 and negative 7.
Oh, you guys are so good. Okay, so now it becomes a negative and a negative, which will still give me that positive 14. Negative 2 minus 7 more gives me that negative 9 I'm looking for. Booyah. So we found our 2 factors. Okay, the hard part's over. Put it in factored form. Our variable is n, so n minus 2 and n minus 7. Wait a second. What am I forgetting? Ricky?
The 3.
Nice. We factored out that 3 at the very beginning, so he still just stays right in front. So final factored form is 3 times n minus 2 times n minus 7. Love it. Okay, let's look at number 6. First thing we gotta check, do they have something in common? Look at your coefficients. 2, 12, and 10. Is there something I could divide all of those guys by? Something they have in common? 2, 12, and 10, Ricky? What was that?
2.
2, beautiful. Yep, I can divide 2 by all those guys. So let's take out our 2. Okay, figure out what's left inside when we take out or factor out that 2. What's 2 divided by 2? 1, so we're just left with k squared on that first guy. What's negative 12 divided by 2?
Negative k.
Ooh, negative 12 divided by 2. Negative 6k for my middle guy. And what's 10 divided by 2?
5.
Positive 5. Okay, so just like number 5, our last guy we did, they had a 2 in common. We factored it out. Now we play the number game with this guy inside. Okay, I like the number game. I need 2 numbers that multiply to 5 but are going to add to the middle guy of -6. Okay, well, what's two numbers that multiply to 5? There's only one option here.
Yeah.
What is it?
1 and 5.
1 and 5. Okay, well, when I add 1 and 5, I get a +6. Am I looking for a +6?
Nope. Oh, -1 and -5.
Beautiful. -1, -5 will still multiply to give me a +5. And now when I add them together, I get that -6 I'm looking for. Booyah. Hard part's done. We found the two factors. Okay, so now all we got to do is put it in factored form. Parentheses, parentheses. This time my variable is k, so k and k. K minus 1. K minus 5. And what am I forgetting? What did we factor out at the very beginning?
2.
2. Put your 2 in front. Love it, you guys. Okay, I'll give you a hint on the rest of these guys, 7 through 10. They don't have anything in common.
Uh-oh.
Do you see any of those, all three of these terms? Can we take out anything? No, that actually makes it easier. We can go straight to playing the number game. Okay? So we're actually skipping a step. Okay, so let's play the number game. Always look at your last number first. This time it's a -8. I need two numbers that'll multiply to give me -8, but add together to give me a +7.
Oh, I hate these ones.
Don't overthink it. Just give me a couple numbers that would multiply to give me an 8, Ricky.
-1 and -8.
Very close. I agree. -1,
And then
+8.
Oh.
I love that she knew that in order to get a -8, one has to be negative and one has to be positive, right? So we chose -1 and +8. Oh, we got it too fast. Yes.
Is it, could you like switch it around? Could it be a -8 and then a +1?
Ooh, I love that question. In fact, let's say that we had gone with that guy first. Let's say it was a +1 that we chose and a -8. Okay. Well, now we add them together. What is 1 minus 8?
1 minus 8, 7.
+7?
-7.
Ooh, are we looking for -7?
No.
We're looking for +7. So did we actually have it right the first time?
If you're looking for a negative.
So if we were yep.
Okay.
If we were looking for a -7 in the middle, that would have been our 2.
Okay.
But then what is 8 minus 1?
7.
+7 we're looking for. So you actually got that one right off the bat. Okay, so we found our two factors. Easy peasy. All we got to do now is put it in factored form. Parentheses, parentheses. Okay, my v and v. I have a -1, so v minus 1, +8. So v plus 8. Love it, love it. You guys are getting good. Okay, we're starting to see how the number game works. Okay, let's keep playing it. What's the first guy I look at?
72.
-72. Okay, so I need two numbers that multiply to give me a -72, but add to give me what? What's my 1 in the middle? Okay,
1 now.
give me some numbers. Let's just test them out.
0, 1.
That doesn't multiply to 72.
no,
Give me
it
numbers
does
that
not.
multiply to 72.
Okay.
Ricky,
1 and 72.
let's try it out. 1, I know one of them needs to be negative, so let's just try 1 and -72. Okay, well 1 minus 72 is going to give me -71. Is that what we're looking for? Nope,
No.
but that's okay. Okay, we crossed it off. It's okay, let's try some more. What are some other factor pairs that would give me 72 when I multiply them together? Ricky?
-1, positive 72.
Okay, so -1 and 72. That would give me a +71. Still not what we're looking for. We're looking for +1 in the middle. How else could we multiply to get a 72? What do you think, Nora? Ooh, I love it. I love it. 9 and 8. One of them needs to be negative, though. Which one do you want to make negative? Ooh. I agree. 9 times -8 gives me my -72. What is 9 minus 8?
1.
Positive 1. Booyah. You see why that's the hardest part? It's kind of just a guess and check method. But once you've found your two factors, it becomes pretty easy. Just put it in factored form. Parentheses, parentheses. My variable's x, so x and x. Positive 9, so x plus 9. Negative 8, so x minus 8. Nice job, you guys. Okay, 2 more examples. Let's keep playing. What number do I look at first?
12. 27.
Which was my last number?
27.
27. I need 2 numbers that are going to multiply to give me a positive 27, but add together to give me 12. Okay, well just think, what are 2 numbers to give me 27? We'll test them out. What can give me 27 when I multiply them together? Ricky?
3 and 7.
Ooh, very close. 3, not 7. 3 times what would give me 27?
Oh. 27.
27 divided by 3, what would that give me?
9.
There we go. Okay, 3 times 9 does give me 27. Ooh, let's add them together. What's 3 plus 9? Ooh. Sometimes you're going to get it right off the bat. Sometimes you're going to have to try a few, and that's totally fine. Okay, we found our positive 12 that we're looking for. Found our 2 factors, so let's go ahead and put it in factored form. This time our variable's n, so n and n. Positive 3, so n plus 3. Positive 9, n plus 9. Nice. Okay, last example. Last number game. What number am I looking at first? What's my
10.
last number?
-10.
Negative 10. I need 2 numbers that'll multiply to give me a negative 10 and add to give me a negative 9. Ricky, what'd you think?
1 minus 1 and negative 10.
Let's try it out. 1 times negative 10 will give me my negative 10. Multiply them together. What's 1 minus 10 now, Ricky?
Negative 9.
Oh, right off the bat. Negative 9 that we're looking for. Found our 2 factors. It's 1 and negative 10. So just put in factored form, parentheses, parentheses, r and r. Positive 1, negative 10. Fist of 5. Before you start your assignment, factoring quadratics, playing the number game. How you feel? What multiplies to this adds to that. Ooh, I like it. I love it. Okay, go ahead, you guys.